Hey guys, in this video, we're going to go over our first lesson with graphing rational functions. A brief overview. Rational functions are functions in the form of a fraction. So when you see rational functions, you should think numerator and denominator. Numerator and denominator. And that's going to be important because we're going to use the rules that we know about dividing numbers in order to find some main features of each of our fractions. They can also come in vertex form. They can be written in vertex form, which is this over here. Notice we still have our A value. Remember, that tells us kind of the direction and end behaviors of our graphs. And then we have our H and K, okay, which is going to be vertex points. This is not quite as straightforward as it was with quadratic and polynomials. So we won't use this a whole lot. We're going to be focusing on the fraction form. Okay, the first characteristic that we're going to start with is a hole. And when we have a hole in our graph, that makes our function discontinuous. So if you think of continuous as a line that keeps going and you don't have to lift your pencil when you're drawing it. So when we have a hole, that is a discontinuity, which means our graph is going and then it's going to jump over a certain point and then it will continue again. So we draw a hole where the graph does not exist or it is not defined at that location, and we write it as the coordinate x comma y. Okay, we also sketch this as an open circle on the function or the line itself. And take note that Desmos graphing calculator will not show you where the holes are. So you actually have to calculate them, which we're going to look at how to do that now. So how do we find the location of a hole? Well, we said before that this is where the function is not defined. Okay, and so what we're looking for is if we take our fraction, right? We said we have our numerator and our denominator. So we have p of x up above and q of x down below. Okay, and we also know with fractions that it is impossible to do 0 divided by 0. So what we're looking for is the same factor in both the numerator and the denominator. Okay, so we're going to factor our polynomials in the numerator and the denominator, those expressions, and then we're going to look for the factor that shows up in both of them. And that x value is where the hole is going to be. And then once we know the x, we can substitute in the x value and find the calculation for the y, and then we have the location of our point for the hole. So in example 1a, we're going to look here. Notice that it is already simplified. Step 1 is to factor. Well, we're already factored, so now we can jump to step 2. Look for the same factor in both the numerator and denominator. X minus 4 is not the same as x plus 4. So we have no common factors. So this is my evidence. No common factors. Okay, which tells me that I do not have a hole. So this would mean that at this point, we're going to assume that our graph is continuous. Okay, no hole means that there should be nothing on my graph. Okay, let's take a look at the second one. Here we have a trinomial divided by a trinomial. So we're going to factor these. Remember way back when we factored, I know 2x squared is going to factor into 2x and x, and I need to factor a minus 1, but I have to have a plus 1 and a minus 1 for these two factors, and I need my bigger number to be minus. So I'm going to put the minus number here so that I get a minus 2x. And then I'm going to put the plus 1 here so that I get a plus 1x. And then when I FOIL, I get a minus x for my b term here in the middle. And then we're going to factor the denominator as well. So x squared gets factored into x and x. And then my factors of 12, for a quick review, I like to draw a table, and I know 12 is 1 times 12, 2 times 6, 3 times 4. Now, if I jump down here to 4, I already have it written. So that pair is already listed, so I'm done. And I am looking for the pair that when I subtract them, because I have 1 plus and 1 minus, I get a negative 1. So that's going to be 3 and 4. Whoops, I just noticed I put x squared instead of x. 3 and 4, so I can put 3 and 4 in. My b term has to be minus 1, so I need the bigger number to be negative. That way when I FOIL, I get minus 4x plus 3x. Okay? And then again, I'm looking for, we don't have an example here. We're looking for the place where we have the factor in the numerator and the denominator. And again, we have no common factors. So there is no holes. Okay. Let me switch colors here real quick and show you what that would look like. Let's say that we have x squared minus 1. Let's do a minus 1. We're going to add this in, guys. So just add it into your extra space on your notes. Okay. And we're going to divide that by an x plus 1. Okay, so we have to factor this. X squared minus 1 is a difference of squares. So that's going to factor into x plus 1 and x minus 1. And then we're dividing by x plus 1. Here's what we are looking for is we have an x minus or x plus 1 here and an x plus 1 here. Okay, so we know that if we plugged negative 1 in, we would get 0 over 0. Negative 1 plus 1 is 0, and it would be undefined. And so my x value, just like when we find our roots and set it equal to 0, my common factor is x plus 1. So I'm going to set that equal to 0, and I know that if x plus 1 equals 0, x has to equal negative 1. So this is my x value for my whole, and then I plug it into what I have left. Okay, so if we were doing regular fractions, these would cancel, and we would be left with x minus 1. So my y value of x minus 1, I'm going to substitute in my negative 1, and that's going to give me a negative 2. So for this example down here, okay, I would have a hole at negative 1, negative 2. And if this were my graph up here, I would go to negative 1, negative 2 and draw a circle. And I know my graph would have to go, it would go through that point, but jump over negative 1, negative 2. Okay. Let's go ahead and look at vertical asymptotes next. These are very similar. However, the difference is the factor is only in the denominator. Okay, so we have to look for the holes first. So make sure that you factor, you cancel out your holes, okay? And then remember those asymptotes are where we are dividing by 0. So our graph is going to approach that line and get closer and closer. So when you think of vertical asymptotes or horizontal, we'll talk about those next, you want to think of end behavior of your graph or what's happening at those arrows going to the left and to the right. Okay, a vertical line is going to cut through the x-axis. So your equation is going to be x equals, and then whatever number value you get in order to know the location. Okay, so just like before, we're going to factor our polynomial. We're going to cancel out any of the holes that we have and put the hole on the graph. And then the remaining denominator factors, we're going to set equal to 0 and solve for x. And just a reminder, if you have an asymptote, you're going to write it as an equation x equals, and you're going to sketch it as a dotted line. I like to make my dotted lines yellow, orange, pink. In that color family, it makes it easy for me to see what the difference is between my graphs and my asymptotes, especially for graphing inequalities and you have a less than with a dotted line, it's easier to keep them straight and not get them confused. Okay, so here's our famous problem A. X minus 4 divided by x plus 4. It is completely factored, so we're good to go there. We do not have any common factors in the numerator and denominator, so we have no wholes. So now we're going to take just the denominator, because remember you can't divide by 0, and we're going to set that equal to 0 to find the location of our vertical asymptote. So if x plus 4 equals 0, then x equals negative 4. So my vertical asymptote for this one is at x equals negative 4. And I am going to draw a vertical line, 2, 3, 4, at x equals negative 4 with my little candy tool. I'm off a little bit. It's hard to know where straight is. There we go. Okay, and that kind of tells me this is where my graph is going to approach. So it's going to get closer and closer to this vertical asymptote. Okay. All right, let's look at the next one. The example B, same as before. Okay, we have to factor this. So this is going to give us, if you remember what we had before, it's going to give us 2x plus 1 times x minus 1. So we get 2x squared minus x minus 1. And we're going to divide that by x minus 4 and x plus 3. Okay, so we factored it. We don't have any wholes to cancel. If we did, we'd have to do that now. And then we're going to look for vertical asymptotes. So we're going to take each one of our denominators. Okay, so we're going to have this denominator and we're also going to have this denominator. So that tells me for this graph, I'm going to have two vertical asymptotes. Okay, so x minus 4 equals 0. So x equals 4 is one of them. And then x plus 3 equals 0. So x equals negative 3 is the other one. Okay, so I have vertical asymptotes at x equals negative 3 and x equals 4. So I will grab my handy dandy orange line and I will go to x equals negative 3. So 1, 2, 3. I'm going to try to draw this in one line this time, see how close I can get. Okay, so there's 1. And then we'll go over to 4 and do the same thing. X equals 4. Try to get it close there. Okay, so now I can see I've got two vertical asymptotes. So that tells me that my graph has got 3 different regions where it's going to be. Okay, go ahead and you can move on to the next lesson. Let me know if you have any questions.